Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 3, Lesson 2 on forms of a line. I think much of what we're going to be doing today is going to be review for you, but let's jump right into it to see different ways we can represent the equation of a line. All right, now there's two forms of a line that are primarily used in Algebra 2. Linear functions come in a variety of forms. The two shown below have been introduced in Algebra 1 and Geometry. Which form you choose in any given problem depends on the information given to you in the problem. So let's take a look at these two forms, which will hopefully seem pretty familiar to you. All right, so we've got the slope-intercept form of a line, also known as the y equals mx plus b form. We have the point slope form of the line, y minus y1 equals m times x minus x1. Now in both of these forms of the line, m is the line's slope, right? The change in y over the change in x. On the other hand, right, b is the line's y-intercept. So that's why we call it the slope-intercept form, because you can see both the slope, right, it's the coefficient of the x, and then the constant term that's added on is the y-intercept. On the other hand, in the point slope form, m still maintains the slope, meaning of the slope, whereas x1, y1 is a specific point that lies on the line, and it can be any point that lies on the line. So one of these is really handy, the slope-intercept, if you know the rate of change, you know the slope, and you know where the line starts on the y-axis, i.e. what its y-intercept is. On the other hand, there's lots of situations where you maybe know the slope of the line and one random point on the line having nothing to do with the y-intercept, and then the point slope form of the line is quite helpful in that situation. All right, let's keep going and working more with these. Here we go. And I'm going to keep putting this thing up at the top just so that we can kind of keep refreshing those two forms, but let's take a look at exercise number 1. Consider the linear function f of x equals 3x plus 5, parentheses, written in slope-intercept form. Letter A. Determine the y-intercept of this function by evaluating f of 0. All right, why don't you go ahead and do that quickly? It should be very easy. All right, well, let's do it. So let me just kind of scroll this up. F of 0 is going to be 3 times 0 plus 5. Of course, any number times 0 is 0, so that's going to be 0 plus 5, and f of 0 is 5, right? Which is the y-intercept. Awesome. Now letter B is a little bit more involved. Let's take a look at that. Find the average rate of change over the interval -2 to 3. Now, we know how to calculate average rate of change. It's going to be f of 3 minus f of -2 divided by 3 minus -2. But in order to do that, we first need to figure out what f of -2 is and what f of 3 is. Why don't we do this problem together? Let's go ahead and do it. So, let's first figure out what f of -2 is. That's going to be 3 times -2 plus 5, which is -6 plus 5, which is -1. I was wondering when red was going to come out. I cannot get rid of the red over that though. There we go. And now let's do f of 3. 3 times 3 plus 5. 9 plus 5, which is 14. Great. So now my average rate of change, delta f divided by delta x, right? F of 3 minus f of -2. All divided by 3 minus -2. That's going to be 14 minus -1. All divided by, let's change that to 3 plus 2. That's going to be 15 divided by 5. And my average rate of change is 3. So my y-intercept is 5, and my average rate of change is 3. Let me just make sure that almost doesn't look like a 5 now that I look at the screen. There we go. Now let's take a look at letter C. Do your answers to A and B match what you know from past work with equations of lines? Explain. All right, well, yes, right? And the reason that we went through this is to verify that the y-intercept is in fact 5, right? That's the plus b. And the slope, which is the average rate of change, is 3, which is the coefficient of x. So the answer is yes. In y equals 3x plus 5, we know 5 is the y-intercept, and 3 is the slope. So as long as we have it written in this form, didn't really want that to be purple, but sure. As long as it's written in that form, then we know that the coefficient on the x term is going to be the slope, and then this, which you can probably now barely see, is going to be the y-intercept. Note to self, maybe it's better to highlight in purple than it is in yellow. Okay, and again, I just wanted to go through that because it's easy enough to sort of memorize that, in y equals mx plus b, m is the slope and b is the y-intercept, but it then plays out in the calculations themselves. All right, let's now play a little bit around with the point slope form, exercise number 2. Consider a line whose slope is 5 and which passes through the point -2, 8. Letter A, write the equation of this line first in point slope form, y minus y1 equals m times x minus x1. Cool. Now never forget, in the point slope, y and x are variables and they should just be left as such. The x1 and the y1 are specific x-y coordinate pair that you are given. And sometimes you know more than one pair and you can use either one of them. This should be very easy though. All I have to do is just do y minus 8 is equal to 5 times x minus -2. Now, technically speaking, there's nothing wrong with leaving the equation of the line in point slope form looking like this. In fact, it's kind of helpful because you can see that the coordinate pair is -2, 8, because we're always subtracting off the coordinate pair. Now, why that is, you should have had developed for you either in geometry or algebra 1, and that's not the purpose of this lesson. Most teachers, though, will recommend that you do just a little bit more simplification on this and rewrite it as y minus 8 equals 5 times x plus 2. So that's going to be our point slope form of this line. Now let's take a look at letter B. Using algebra to manipulate your answer from A, write the equation of this line in slope-intercept form, y equals mx plus b. Now, what's kind of interesting about these two forms of a line is that there are an infinite number of different point slope forms for a given line, but there is only one slope-intercept form. And we can easily take any point slope form, maybe easily is the wrong way to put it, but we can take any point slope form and we can just use some basic algebra to rearrange it into slope-intercept form. Let's do that together. Again, pretty simple. So what I'm going to do is I'm going to just start with y minus 8 equals 5 times x plus 2. What I'm always going to do first is distribute the slope through that parentheses. That's going to be 5x plus 10. And then I'll just add 8 to both sides, and I'll find that the slope-intercept form of this line is y equals 5x plus 18. And perhaps you want to do that just simply because you want to know what the y-intercept of the line is, right? Now it's easy. The y-intercept is 18, which is not obvious when we look at this particular form of the line. In both cases, you can easily see that the slope is 5, but it's a lot harder to see the y-intercept in this form than it is in that form. Maybe you don't need the y-intercept, so maybe you don't need that form at all. Let's keep going. Parallel and perpendicular lines. Now, we should feel comfortable with parallel and perpendicular lines from geometry and how their slopes relate. If you've already taken geometry, which most people have before Algebra 2, there is a ton of work on slopes with parallel and perpendicular lines. So let's take a look at exercise number 3 and see if you can remember what's going on. Exercise 3. Which of the following represents an equation for the line that is parallel to y equals 3/2 x minus 7 and which passes through the point 6, -8. All right, pause the video now and see if you can figure out what the correct choice is. All right, well, one of the big things in geometry was that parallel lines have equal slopes. Let's write that down, all right? Parallel lines have equal slopes. Okay, so that means that the slope of the line that we're looking for is 3/2, right? It's got to be 3/2. One way or another, the slope of this line is 3/2. So if I've got a parallel line whose slope is line that's parallel to it, it must also have a slope of 3/2. Now, all of these particular lines are written in point slope form. And we can immediately say that choice 1 and choice 4 cannot be correct because they do not have the correct slope, right? They have a slope of 2/3 here, -2/3 there. Actually, both of them are -2/3. I just misread the board. All right, so it's either got to be choice 2 or choice 3, both of which are written in this point slope form that has a slope of 3/2. Now we just have to do our little y minus y1 equals m times x minus x1. Right? So we're going to have y minus -8 is equal to 3/2 times x minus 6. And that's going to be y plus 8 equals 3/2 times x minus 6. And that is going to be choice 3. As long as I can find it. There it is, choice 3. Simple enough. Now let's do a little work with perpendicular lines. Here we go, exercise number 4. The graph of a linear function is shown. Write the equation of this line in y equals mx plus b form. All right, so what I'd like you to do is pause the video now and figure out what the equation of the line is that's been graphed in y equals mx plus b form. Well, figuring out b is pretty easy, right? Because that is simply the y-intercept. So that's simple enough. You know, b is equal to 3. A little bit more challenging for the slope, but as long as we just sort of take a look at points on this, what we can see, right, is that our slope, which is the change in y over the change in x, is 2 units of rise in y per 1 unit of run in x. So that's just a slope of 2, which means the equation of our line is y equals 2x plus 3. And of course, you could say 2 over 1 times x plus 3, but most of the time when our slopes are integers, whole numbers, plus or minus, then we don't put a denominator of 1 there. So y equals 2x plus 3. Letter B. What is the slope of a line perpendicular to the one shown? All right, now this goes back to geometry. Pause the video now and see if you can remember what the slope would be for a line that's perpendicular to a slope, or to a line whose slope is equal to 2. All right, well, perpendicular lines have slopes that are known as negative reciprocals. So if a slope is equal to 2, then the perpendicular slope is -1/2. And this is where it would be kind of helpful to think about the slope as 2 over 1, because then the perpendicular line has a slope of -1 over 2, or -1/2. Letter C. Draw a line perpendicular to the one shown that passes through the point 1, 5. Awesome, cool. So now what I'm going to do, I'm going to just kind of erase these. I think I'm going to go into red just to give us a nice contrast. There's our point 1, 5. Now what I need to do is I need to then use this slope, right, where we'll have a change of y of -1 and a change of x equal to 2. So I'll go down 1 and to the right 2, down 1 to the right 2, etc. I could also reverse that and go left 2 and up 1, etc. And I will then have a line that looks something like this. Move this out of the way. And there's our perpendicular line. And you can really see it, right? That beautiful right angle. As long as my graph paper is square graph paper, the right angle will be rather obvious. Okay, now let's take a look at letter D. Write the equation of the line you just drew in point-slope form. All right, you have everything you need. You've got a point that the line goes through. You actually have multiple points the line goes through, but probably use the point 1, 5. You've got a slope of the line, -1/2. Now you can write the equation of the line using that slope and that point. Pause the video now and go ahead and do that. All right, well, I think I'll stick in red just to kind of emphasize that we're talking about that perpendicular line. I know my slope is -1/2. I know that it goes through the point 1, 5, and therefore I can say y minus 5 equals -1/2 times x minus 1. And now I'll go back into blue. Back to blue. Okay, fantastic. So now we've got a point-slope form of the line. Let's take a look at letter E. Does the line that you drew contain the point 25, -7? Justify. Well, what I'd like you to do is try to figure that out. Obviously, we haven't got a grid that's long enough to see whether or not it goes through 25, -7. So why don't you go ahead and see if you can figure that out algebraically. Well, this gets to a larger picture, right? And the larger picture is this point is going to lie on this line if when I substitute this point into this equation, it makes the equation true. So I'm going to put in 25 for x, I'm going to put -7 in for y, and if I get the same thing on both sides, that point lies on this line. And if I don't, then it doesn't. It's pretty much that simple. So let's do it. Let's check it. All right. So I'm going to put -7 in, -5. Maybe put a little question mark above that. Question mark, does that equal -1/2 times 25 minus 1? -7 minus 5 is -12. So question mark, -1/2 times 24. And -1/2 times 24 is -12. So that's true. And the answer is yes. All right, and that's really, really critical, right? I mean, you've been seeing that probably since middle school, this idea that a point will lie on the graph of a given equation if it makes the graph, or if it makes that equation true when substituted in, and it won't fall on that graph if it makes it false when substituted in. All right, let's keep going. Writing an equation if given 2 points. As you learned from geometry, through any 2 points, there's only one line that can be drawn. It is critical that you're able to write the equation of any linear function if you were given 2 input-output pairs, right? The only way that this won't be a linear function is if the 2 input-output pairs create a vertical line, but that should be pretty obvious, and that's not what we're concentrating on right now. So let's take a look at exercise number 5. A line passes through the points 5, -2 and 20, 4. Letter A. Determine the slope of this line in simplest form. All right, well, you've figured out slopes of lines many times using 2 coordinate pairs. Pause the video now and go ahead and do that. All right, well, the slope formula is also the average rate of change formula. We worked with that a lot in our last lesson and also in previous lessons in this course. So slope is change in y over change in x. I'm going to do 4 minus -2 in the numerator and 20 minus 5 in the denominator. That's going to give me 6 in the numerator, 15 in the denominator. And I think I'll reduce that. Considering that both 6 and 15 can be divided by 3, I'm going to find that the slope of my line in simplest form is 2/5. All right, great. Let's take a look at letter B. Write an equation of this line in point-slope form. Now, point-slope form is an extremely sort of easy way to write the equation of the line because we have the slope And we've got 2 points to choose from. Which one should you choose? The answer is, it does not matter. So pause the video now and go ahead and write the equation of the point-slope form of the line, and equation in point-slope form for this line, using either one of these points. Go ahead and do that now. All right, well, I'll do them both just so that you see both of the answers. For the point 5 comma negative 2, we could do y plus 2 is equal to 2/5 times x minus 5. That's if you're using that first point. Or I could do y minus 4 is equal to 2/5 times x minus 20. Either one of those are perfectly acceptable. Either one, and they are actually algebraically this equivalent. It's just hard to see that in these forms. Now let's take a look at letter C. Write an equation for this line in slope-intercept form. All right, well this, right, means you got to do what we did in that previous problem. You have to algebraically manipulate one of these two, and it shouldn't matter which, because either one of them should lead you to exactly the same slope-intercept form of the line. Now this one's a little bit more dicey because you got to multiply by a fraction, and anytime yet fractions are involved, things apparently get a lot more difficult. I've seen it time and time again. So pause the video now and see if you can come up with the slope-intercept form of this line. All right, well, it doesn't matter which one you manipulate. I'm going to manipulate the first one. So I'm going to start with y plus 2 equals 2/5 times x minus 5. The first thing I'm going to do is multiply through this parentheses by that 2/5. Of course, 2/5 times x is just 2/5 times x, and 2/5 times negative 5 is negative 2, because the 5's cancel and you're just left with the 2. Now I'll subtract 2 from both sides, and I'll find that y equals 2/5 x minus 4. And that is the equation of our line in slope-intercept form. If you had manipulated this one, you would get exactly the same answer. So if you got a different answer and you manipulated this one, and you're thinking, well, it's just because I chose the other one, you should get exactly the same thing. Final problem, letter D. For what x value will this line pass through a y value of 13? All right, this is kind of similar to our previous problem where we asked whether or not the given point even lied on the line. See if you can figure out what x value will give you a y value of 13 on this line. Well, we simply need to set y equal to 13 and solve. All right, and a little bit messy again because of the 2/5 fraction, but I'm going to put 13 there. 2/5 x minus 4. I'll add 4 to both sides, and I'll get 17 is equal to 2/5 times x. Multiply both sides by 5/2. That tends to be the easiest way of getting rid of all of this. 17 times 5 is 85. Divided by 2, I suppose you could leave it as 85 halves, or you could do 42.5. I think that's maybe the nicer way to leave it. So, x value of 42.5, I know it's kind of ugly, but an x value of 42.5 will give you a y value of 13. Okay, let's do one last problem. Exercise number 6. A hot air balloon begins to rise. After 20 seconds, it is 78 feet above the ground, and after 32 seconds, it is 120 feet above the ground. Create a linear function for the height of the balloon h as a function of the time since it was released t in seconds. All right, well, what I'd like you to do is pause the video now and go ahead and go through this. Awesome. Well, there is nothing in this particular problem that says what form we have to leave it in or anything like that, but let's first lie out the 2 coordinate points, right? One of the points is going to be 20, 78, and the other point is going to be 32, 120. So I think that the first thing I should do is just simply figure out the slope, right? The slope, which is, I guess, maybe we'll do the change in height over the change in time. You could use y and x, but I'm going to use h and t, is going to be 120 minus 78 all divided by 32 minus 20. 22, 20, that's going to be 42 divided by 12. Both of those are divisible by 6, so that's going to be 7 halves, or if you like, 3.5. Right? Now, one of the things that's kind of neat is this is an applied problem. So like literally that slope has got units. Now, I didn't say you had to put the units on, but just for a second, right? The 78 and the 120 are in feet. The 32 and 20 are in seconds. So that's 3.5 feet per second, right? The balloon is rising at a rate of 3.5 feet per second. Now, how do you want to leave the final answer, right? You could do point slope form using this, point slope form using that. You could also do slope intercept form, etc. But there's many different ways you can leave it. I could do h minus 78 is equal to 3.5 times t minus 20. That would be a good equation. I could do h minus 120 is equal to 3.5 times t minus 32. Or I could algebraically manipulate that, and I don't think we're going to take the time right now to do it, to get h as a function of t in slope-intercept form, right? All of those are acceptable because it simply says create a linear function for the height of the balloon h as a function of the time since it was released t in seconds. All right, let's wrap this up. Now, today's lesson really should have been complete and utter review. In other words, you've been looking at forming the equations of lines in slope-intercept form since probably 7th or 8th grade. And you've been seeing the point-slope form of a line either since Algebra 1 or geometry, depending on when it was first introduced to you. Both of these forms of lines are really, really helpful to know, and you certainly need to be able to take any two coordinate pairs and come up with the equation of the line that goes through them. All right, that's absolutely critical. Which form of the line that you use depends on, well, what did the question ask? Was it multiple choice? Which way do we want it? Do we need to know the y-intercept? Do we just need an equation, right? What do we have? What do we want? Which form makes the most sense? You'll get a lot of work with linear functions throughout this course. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.